So I am not a real technical person when it comes to concrete. As a matter of fact, growing up in Western PA, we used to call everything was cement. You know, we had a neighbor who was getting a driveway poured. We'd say, hey, let's go watch the cement truck. So it took me a little while working at SEFA, getting smacked a couple of times. Bill, cement is to concrete like flour is to bread, right? So I finally got that in my head, but it took me a while. So a lot of these presentations I've sat in, this is my first time at an ACI event, and a lot of that stuff is going right over my head. So you might want to ask some questions of these guys about specifically how ash works in concrete. What I'm going to talk a little bit, my experience, I'm a project guy, been involved in beneficiation facilities for going back to the late 90s. So that's kind of what I'm going to talk about, pretty much at high level, and just give you an overview of how coal ash is processed. I think these guys did a great job of giving you an overview of what coal ash is and all of that fun stuff. So, as Bill mentioned, I came to work for SEFA a little over 20 years ago, but almost 2 years ago, we were acquired by Heidelberg Materials. I think everybody here knows who Heidelberg is. Very aggressively involved in lowering the overall CO2 footprint of concrete. At SEFA, we have a long history of beneficiating ash. We were in business about 47 years before we got acquired by Heidelberg. And back in 2015, we actually started processing harvested coal ash. Number of reasons behind that. At the time, everybody in the industry looked at us like we were crazy. But to date, we have processed over 7 million tons of harvested coal ash. So I think everybody's aware of some of the benefits of recycling fly ash. Obviously, there's the environmental side. You're reducing the waste in landfills and any potential for heavy metals and other materials to leach out of that. Energy efficiency, because the more ash you use, the less cement you have to use, which is a lot of energy intensive process to manufacture cement. So obviously cost savings, because ash is typically cheaper than cement. And then, it's improving the sustainability of construction and improved material properties. I'm sure kind of everybody in the room is aware of ash and concrete improving ultimate strength and greater durability and all of these things. So Cole did a really good job of explaining how ash got into these ponds and landfills. Sometimes a landfill will be referred to as a dry stack. I learned something along the way in doing all this, and as we talk with civil contractors, their definition of dry is very different from what I consider to be dry. And typically they'll be, it's only 25% moisture. Well, to us, that's wet. But a lot of these deposits, the impoundments, really an alluvial deposit, right? So over time, there's different layers. They're depending on where the sluice line was. You have heavier particles drop out. So these things, it's very important to do characterization when you're going to harvest. But traditionally, these materials, the material that was beneficially used, the marketer would take it, and the majority of it, when you look at the total tons, and it's been pretty consistent, you look at the ACA data, probably about 12 million tons of fly ash is used in concrete products. Some, not quite as much, a couple million tons go into the actual cement manufacturing process where it goes into the kiln itself. Now, when we look at, a lot of people call it fresh fly ash or production fly ash. Historically, some of the issues with increasing usage is because of the demand and supply of the material. So these lines here, the red line represents if you look at generation on a month-to-month basis, coal-fired power plants typically are running at their peak in the winter and in the peak of summer, and really doesn't line up very well with the demand when concrete's being poured. So there was always, the green bars here kind of represent, if I were to take a 300,000 ton, let's say, source of material, and I look at the cement shipments by month, and I proportion that accordingly, and I do the same on the net generation month by month, I wind up with a disparity here. So you can see that in January, it's probably close to 15,000 tons that could not be used in the market and would need to be disposed of. And likewise, in October, in the tail ends, there's a great disparity, and you have a need that there's demand for the material, but it's not being produced. So that's why historically there's a lot of ash that wound up. It's not only just a quality standpoint, it's that supply and demand disparity. So let's talk a little bit here about harvesting. We did a good job of not too much duplication, but I know Cy had this same slide, and we all have talked about this 2 billion tons of ash that's in the ground. And again, some of that may be commingled with other wastes, as we said. And the logistics behind trying to move this material to where it's needed, obviously where population is, that's where concrete's being poured, right? So this isn't a material that has a tremendous value. So as you have to move it, freight plays a big part in the use of ash. So some of the benefits too, I always say in our business, we kind of have two customers. We've got the utility. We're trying to provide service for them in utilizing ash, minimizing their disposal, improving their O&M costs. But then obviously, we've got our concrete customers who are using the material. But one of the benefits on the utility side is that this helps as part of their closure process, right? And so as ash is harvested and beneficially used, they can then clean the site up and redevelop it. So the key here is, again, not all ash is created equal. The quality aspect of it, some of the material to be used needs to be beneficiated. Talked about C618 and some of the key components here. Make sure from a prescriptive standpoint, right, that the chemical composition is right. You got to control moisture, fineness, and then the big one, loss on ignition or carbon. Any harvested material is going to have to go through a number of steps in order for it to meet specifications. We talked about drying, then classifying. A lot of these deposits are a mix of fly ash and bottom ash. It's rare that you have a high quality source of fly ash that you won't have to do anything with. But even then, you'd still have to dry it, right? So there's the classifying step, and really the intention there is to separate the fly ash fraction from the bottom ash fraction. Grinding, you can take that bottom ash and maybe you can find another market for it, or maybe you dispose of it again if that makes more economic sense, or you grind it to get it within the specification. And we'll talk about carbon treatment a little later. But as far as drying methods go, rotary dryers are very popular. Fairly low cost from a CapEx, OpEx standpoint. Flash dryers, so there's pretty much not any real rocket science here, right? This is pretty much off-the-shelf type of equipment. Same with screening and classifying. There's a number of different methods you can use. Air classifying, vibratory screens, and then grinding, vertical mills, ball mills. There's a number of different ways to take that coarse fraction and be able to get it into specification. So the real magic, the secret sauce, is on the carbon treatment. I was always surprised when I first came to this industry how much carbon is left over on ash. And 25, sometimes as high as 25% carbon left on ash. I would say in our experience at SEFA, we've beneficiated over 20 million tons or close to it. Probably average 8 to 10% LOI. And some of that's the region. Most of our applications are east of the Mississippi, so we're dealing with a lot of bituminous coals. A lot of regulated utilities where fuel was passed through to the ratepayer, so they're not too concerned about efficiency and trying to get that carbon down. So when you look at LOI, there's a point where you can passivate it. And there's a number of different methods to do that. You can use a chemical treatment. It will make the ash perform better, is the intention. Now the big thing though is, and a lot of people don't quite appreciate that, from a prescriptive standpoint, yes, the ASTM says 6%. But just because you have a material that's under 6% does not mean it's going to perform. I can tell you from experience, we've got a couple sources of byproduct ash that are not beneficiated. And it may be 2.5%, which everybody would think, oh, 2.5%, that's really good stuff. And it works well. But then when it gets to 2.7%, creates all kinds of air and training issues with the ready-mix folks. And that, when they will use more, ready-mix producers will use more ash when it's consistent, when they know it's always going to be the same day in and day out. Now, really, you get over the 6% limit, and now you're talking, really, you're going to have to try and remove that carbon. Even if you were able to chemically passivate it and treat it, it may be bleed black when they put the mix up and what have you. So really, over that limit, the best thing to do is to remove the carbon. So how do you do that? There's a number of commercial techniques. As I said, you can passivate it. That only works up to a certain LOI. You can remove it either through separation or combustion. I think Cole had a slide up that showed an ESP. And so there's a company called Separation Technologies owned by Titan. They've developed with this triboelectric separation, which is basically the same concept. You charge the particles, you pull the high carbon out of the ash. There are methods to try and classify, like air classification. If you have a consistent, the carbon's always coarse or the carbon's always fine, not always the case. There's froth flotation that really hasn't been commercialized in the US, and a lot of that was because if I had dry ash, I had to get it wet, and now I've got to dry it again once I get the carbon out of it. So there's very energy intensive. Our experience is mostly with combustion, different types of fluid beds, where, and our patented STAR process, where we can take any amount of carbon, we've processed up to 25% and get it down under 1% LOI. I think Cole said something about no pond or landfill is the same. And that's a true statement. And when you develop a solution for beneficiation, there's no cookie cutter, there's no one size fits all. It's going to be a combination of techniques and processes. And one of the things that we failed to appreciate early on when we were doing this was how important that characterization process is. And really you have to treat it like you would in a quarry, or you've got to kind of come up with a mining plan, right? Because the more you can get consistent feed on the front end, maybe blending or what have you, but at the end of the day, you're going to have to design your beneficiation facility to handle all kinds of different characteristics, whether that's LOI, moisture, or particle size. So really there's, we said that you can classify, separate, you got to dry it first, you can take that oversized material, you can grind it, you can look at different markets to send this to, but really any beneficiation facility is going to be a combination of different steps. Typically, because of the logistics and the transportation limitations, you typically will build one of these facilities adjacent to the source of the material. And a lot of these impoundments will be a series of different impoundments at these utilities. There may be 3, 4, 5 different impoundments totaling 5 or 6 million tons. There are some power plants that have 20+ million tons deposited on their site. So typically when you're harvesting that material, they'll harvest it and windrow it to kind of decant it, and this gets back to the dry versus wet, but get it really down to under 25% moisture. There is a certain, really not going to get it down below probably 15 to 18%, because there's that inherent, that moisture will stay with the ash. Once it's decanted and get pre-dried, so to speak, then you can screen it to get out, and really the intention of screening is to remove kind of debris, rocks, wrenches. There's a lot of different things that have gone into these landfills and impoundments. Part of the characterization piece, if you can find boots on the ground people who know kind of where the dead bodies are, so to speak, that's always very helpful. Once that material is you get it down to about 25% moisture or less, and you screen it, and typically that screen's about 3/8 of an inch, 1/2 an inch. Then you can take it over to the beneficiation facility where it'll run through and you can dry it, classify it, grinding and carbon treatment optional depending on what the source material is. So one of the things that you need an appreciation for when you're doing this is variability. So this is an example of some feed and product LOIs from a thermal plant. But you can see that just the variability can be extreme. Cole mentioned, they might have changed coals they were burning. They might have blended different coals. So all of those things in the operation of the unit itself, whether they were running at low load or high load on the boiler, that can influence things like LOI and the proportion between fly ash and bottom ash. So all of these things, for LOI and particle size, the variability can be extreme. And so you got to make sure that you design your process to handle all of those, or at least be able to maybe segregate it, and you only process a certain portion of the material. But at the end of the day, any beneficiation program, the goal is consistency. This is an example of a material that was about 10% LOI on the left and about 20% moisture, and that's a product on the right that's about 0.5% LOI and 0% moisture. So as I noted earlier, the concrete producers want consistency. And if you can get them a consistent quality product, they will use more of it. They'll put it in, they'll put it in more mixed designs. They'll push their replacement rates. One of the game changers with harvesting is the consistent supply. So I showed you earlier that graph that showed the disparity between ash being produced and the demand in concrete. Now that you've got material underground, millions of tons, you can supply the market when they need it, which in turn means they're going to use more of it. So it's kind of a double benefit, beneficiating, because you got the tight spec on the quality of it, and you can make it readily available when they need it. This is an example of so you can see these things are not, everybody's always looking for that silver bullet. Something you can just roll in, set up, run it for a couple of years and roll it back out. When you're looking at trying to, and obviously there's economies of scale, right? So these plants run 24/7, staffed with probably 20 to 25 people. So to do this and make only 50,000 tons a year doesn't make a lot of economic sense. So there's those economies of scale. I can I can design a facility to process 1 million tons a year if the market was there for that material. But so you can see that this in particular, again, like I said, you've got, here's some impoundments. This facility was built adjacent to those impoundments. You've got raw feed on this end, you're drying, this is carbon treatment, this is actually a scrubber on the back end, and then product storage. And when we talk about storage, so again, not being able to just, this isn't some pop-up, you set it up and you can tear it down. You've got to be able to bridge weather events, dips in the market. This particular facility has already been running for about, not quite 5 years, had 3 hurricanes come through. So, you've got to be able to ride that out. Typically on the front end, you'll design for 3 to 5 days worth of storage, so at least you can get through a weekend. Typically the harvesting operation and excavation is only 4 or 5 days a week. The facility's running 7 days a week. And then more importantly, on the back end is product storage. So a lot of folks think that you can just pop up a 300-ton silo and be able to ride, through the ups and downs of the market. This particular facility's got about a month worth of product storage. So that helps to ride out, the seasonality of the market, but as well as other, you may have 2 weeks where it rains every day. That allows you to ride that out. Average sales, probably in the 1,200 ton a day range. So talk a little bit about the difference, what you're harvesting versus what the product is, right? So the goal is to maximize the amount of material, the product that you'll get. But when you think about, you're gonna have that, I said we do that pre-screening, so you're gonna have some amount of trash and debris. There's gonna be a significant amount of moisture. And then if you're doing carbon removal or you're burning the carbon or you're pulling the carbon out, there's a certain percentage there. So from about 500,000 tons that go to the facility, about 340 would be available for sale. And in this particular application, the bottom ash is being separated after drying and then ground in a ball mill to meet spec. So big picture, you look at the reject, the mass percentage, the waste streams, the overburden, underburden, you may have biomass mixed in there. So that's usually going to run no more than 10%. A lot of times it's more in that 2 or 3% range. It's the majority of that material that you're going to find in that landfill or in that impoundment. It's fairly consistent from what it is. It's coal ash. You may have commingled waste. So there are, you look at those 2 billion tons that are in deposits in the U.S. Well, some of those may have been commingled with FGD, and at this point in time, not economical to be able to recycle that, harvest and recycle that. You may have non-spec streams from your beneficiation process. So I said earlier, you may decide, I'm going to screen the bottom ash and coarse material out, and I'm going to redispose of it because I don't want to put in a grinding circuit to have to grind that. And then depending on the beneficiation process itself, you may have other waste streams. With the electrostatic separation, you've got that high carbon fraction that you got to do something with. With thermal treatment, you really have the ability to, have almost zero waste stream except for the small amount of your own FGD you may make from a scrubber. So really that's it. Summary and conclusions. I think we all know about the benefits from an economic and technical standpoint of using ash in concrete, the environmental aspect of it, being able to lower the global CO2. And then there's the logistic challenges, and production ash, as Cy showed, is going away, right? And so there's this ability to continue to provide SCM to the market with harvesting. And probably the one major lesson that I have learned in my 20 years of beneficiating ash is that it's no one size fits all. It's not a cookie cutter solution. Everything has to be tailored to the type of material you have and the amount of material you have. I think that's it.